Today we will talk about how to draw, how to transform cyclohexane constituent groups into a chair conformation for cyclohexane. And we will talk about which ones are equatorial and which ones are axial and how do we tell the difference. And we will also talk about how to interpret between the two chair conformations. So those two. And how to take groups from this to this and from that to that. So let's go ahead and just draw some random thing. I'm just going to go ahead and draw a bromine coming into the page. Okay, and then on this one I will draw an OH group going into the page. I think this one's out of the page, that one's into the page. And then over here I'll just draw a methyl group. Just, something. Right? So first things first is I'm going to decide, am I going to be drawing these counterclockwise or am I going to be drawing them clockwise? Okay? And it doesn't matter. It's not like you have to pick priority for certain groups. You just make a decision and you stick to it, and then your results should be correct. So just for the heck of it, I'm going to go ahead and do it counterclockwise, and I will randomly assign a carbon. I can say this is my carbon number 1, this is 2, 3, 4, 5, and 6. As you guys can probably guess, you can start anywhere on this ring and it wouldn't make a difference, right? So the reason I said to make sure that you pick one and stick to it is because when we come here, I'm also going to be naming them or adding them counterclockwise, right? So actually, before I can even start doing this, what I'm going to go ahead and have to do is I'm going to add the groups. And I have a very quick way of showing you which is equatorial, which one is axial, and it's all about up versus down, right? Okay, so what do I mean by that is this. So we're going to start at this carbon. Let me do that in pink. We're going to start at this carbon right here. And it's pointing down, so I'm just going to draw something pointing down from it, right? Then we're going to go at this carbon right here, and we're just going to draw a line going up. Same thing for this one. A line going up, right? Here this one's kind of pointing down, so we're going to draw a line pointing down, line pointing down, line pointing up. So as you guys can see here from my picture, these are all the axial. Everything that I just drew in pink is the axial substituent, right? I'm going to use green now to draw the equatorials. So now this is where this really comes into play. Here we're going to have to make a decision, right? So I'm going to see, based on what I just drew, was this up or down, right? So this is down, this one right here. So that means I'm going to now have to do, up, right? So I'm going to draw an equatorial carbon pointing up. Let's go to this one. This one is pointing up, so I know that I'm going to have to do the opposite and point down, right? Same thing for this one. This is up, and this one is at an angle, obviously, but down. And actually, this one right here isn't actually leaning to the left or to the right. It's actually pointing straight at me, but it's kind of hard to draw, so we just draw it like this, right? Next, we move on. This is pointing down, so we'll point it up at an angle. Pointing down, so we point up, and then pointing up, so we point down. Everything I just drew in green was equatorial, right? Cool. So I'm going to go ahead and actually erase some of the things I just drew on here so that we can free up some space so that we can actually begin our drawing. Okay, but let me go back to this one and I say, okay, so I decided I was going to do counterclockwise, so this one will also be a counterclockwise, right? So it doesn't actually matter which carbon I start on this one, but I will just randomly pick this one as my number 1, and I will go from there, right? So if this is my first carbon, I can see that there are only 2 groups here, and they're both hydrogens, so I will just add 2 hydrogens on here, right? And it doesn't matter which one's which, because it's not this carbon here, this is actually not what is the word for it? Oh god, I just forgot. It is on the tip of my tongue. This one is not, it'll come back to me. Give me a second. But basically what I'm trying to say is, it's not like it has 4 different groups, it has 2 of the same group, which is hydrogen, right? Anyway, so let's move on to group number 2, carbon number 2 I mean, and you guys can see that there's a bromine sticking out at me. So here is the convention. Here's what I will decide. I'm going to decide that everything that sticks out, I will designate it as up. Those are equal. Everything that goes into the page, I will designate it as down. So bromine is pointing, it's coming out towards me, so I'm going to say, hey, this is up, and this is my carbon number 2, so I'm going to pick which of these is pointing up. It's not the axial one, it's the equatorial one. You guys can see that it's pointing up. So here is where I add my bromine. So let me erase this arrow so it doesn't confuse you. But I'll add my bromine. And even though it's not showing, I can assume that there's a hydrogen behind here, right? So I'm going to add a hydrogen there. Next, we're moving on to carbon 3. There's again nothing, so I'll just add 2 hydrogens. And then carbon 4. I have a hydroxyl group going into the page. So I already said from my naming system that I was going to say that that is down. So this is my carbon 4. Which of these 2 is pointing down? Well, it looks like it's the axial one, so I will add my OH group here, and then an H over here. And then 5, again, 2 hydrogens, nothing special about that one. And then 6. 6, I actually did not put one, but I will randomly assign it going out. I can add here, I don't know, let's say an NH2 group, but I can also, add something going into the page, and that one I could just say it's randomly, I don't know, a pH or whatever, you know what I mean, right? So let's do it. Let's start with the NH2. So we said this one was going to be up. So the only one that is up on this carbon, which is carbon number 6, is going to be the NH2. And the only thing that was going down is the phenyl group, pH. Right? So step 1, I can check it off because step 1 was going from this to that. That is my step 1. Now to go to my step 2, which is just a tiny bit trickier, but not that tricky, right? From here to go between chair conformations, I'm going to make sure that I do not change up or down. So in other words, whatever is up will stay up, whatever is down will stay down. And let me show you how that works. But before I do that, I'm going to go ahead and add in all my substituents, right? So again, this is pointing up. I'm going to point a line straight up, pointing down, a line straight down, point up, point down, point up, and point down, right? Then I'm going to say, okay, I'll go carbon by carbon and say this one's pointing down, so it has to, this is pointing up, so the next one points down. This one's pointing down, so this one has to point up. This is down, so up, down, so, up, so down, down, so up, so down. So these are the things. These are the axial, equatorial, kind of like substituents, even though I haven't added anything in yet, but this is going to be the backbone for what I add in. So now we're going to forget. We're going to forget this exists, and we're going to zoom in and pretend that these are the only 2 ones that I have in front of me. And then I'll go again, carbon by carbon. If this was my number 1, then I will stick to that nomenclature and say that this is my number 1. I don't know if you guys can tell, but I will use this. This tip right here is the same as this, but pointed up, right? And this right here is the same as this, but pointed down. So this carbon, which attaches to this carbon, is really just this carbon, which attaches to that carbon, right? So that's something that you want to make sure that you don't mess up on, because it's actually really important. So this is my carbon 1, this is my also carbon 1. And again, this doesn't matter. I'll just put hydrogens and hydrogens here. Next, carbon number 2. So on here, my bromine was up and equatorial, right? So I have to make sure that it's up again. So if we go down to carbon 2, the up position is now axial, right? So it's still up, but now we've switched the equatorial to the axial. And what you could do is you could just go ahead and memorize that. You could memorize that if it's axial on one of the conformations, it's going to be equatorial on the other. Or you could memorize the system, which is the up or down system. And I honestly prefer this because I don't have to think about it. I just do, right? Carbon 3, both hydrogens here, nothing special. And then carbon 4, this is carbon 4. We have the hydroxyl group pointing down, so I have to make sure that the hydroxyl group points down here. And this points down, so this is where I'm going to put my OH and hydrogen here. So let's go back a little bit and compare the two. Over here, my hydroxyl group is axial. Over here, it's equatorial, right? And then carbon 5 is just a hydrogen and a hydrogen. And then the very last carbon, carbon 6, I have an NH2 group pointing up, so I add the NH2 here. And then I have a phenyl group pointing down, so I add it over here, right? And again, the NH2 was equatorial and now it's axial. The phenyl group was axial and now it's equatorial. So this is how you go from step 1 to step 2. Actually, this is how you go from step 0 to step 1 to step 2, right? So this should be a pretty good explanation on how to intercovert between the three. I'm going to end my video here, and you guys, if you guys can like and comment and tell me what else you would like to see for my future videos, I will make some more. Alright, bye bye.